Hello and welcome to the NFPA LiNK YouTube channel. This page is dedicated to answering key questions you have related to electrical and life safety. With easy-to-use digital access to NFPA codes and standards, NFPA LiNK is your window to productivity. Today, we've been asked to cover photovoltaic system maintenance using the 2023 NFPA 70B standard for electrical equipment maintenance. So from my desktop in LiNK, I'm going to navigate to the 2023 edition of NFPA 70B. And I know that Chapter 30 covers photovoltaic systems. So the scope of this chapter in 30.1 states that it is to identify electrical maintenance requirements for solar photovoltaic or PV systems and its associated equipment. From there, the chapter is broken down into three subsections. The first being in 30.2, frequency of maintenance, then in 30.3, documentation and labeling, and finally in 30.4, periodic maintenance procedures. So we'll see those periodic maintenance procedures mentioned again as we scroll back up to 30.2 because those are what your tasks specifically are that need to happen as part of the maintenance that happens. 30.2 designates how frequently that maintenance needs to happen. So in 30.2.1, periodic maintenance procedures in section 30.4, which we just looked at, shall be performed in accordance with the frequencies in chapter 9, unless otherwise specified in the chapter. So within LiNK, when you're using this and you see these bold underlined items, that gives you a hyperlink right back to that section. So I'm going to click on the chapter 9 so we can go back there and look in 9.2, which is frequency of maintenance. So 9.2.1 is important because it mentions manufacturer's recommendations shall be followed for each of the maintenance scopes specified in this standard for the required intervals. So it's important to keep in mind when using NFPA 70B that if the manufacturer of the equipment tells you specifically how you need to maintain that equipment, then you need to do that according to what they tell you. Now, if there are other components of it, maybe visual inspections or things like that that the manufacturer doesn't mention, those can be supplemented by NFPA 70B. Or if the manufacturer doesn't give any instructions altogether for maintenance, which can be quite common, then with that, you're going to go ahead and use NFPA 70B in order to do all the maintenance that's required based on that standard. So if we go down into 9.2.2, we can see that there's a table in there that gives us maintenance intervals based on specific products or equipment. So right here you can see on the first row, all equipment is recommended to have infrared thermography take place at different intervals based on three different conditions over here. So we've got condition 1, 2, and 3, and we can see that for infrared thermography, condition 1 says it shouldn't happen any longer than 12 months. Condition 2 is again at 12 months in this case, and then condition 3 is at 6 months. So what are those conditions? So if we go back out of this table and scroll down a little bit in chapter 9, we can see in 9.3 there's equipment condition assessments, and 9.3.1 breaks down those specific conditions as to what the criteria is, so you can understand what the condition would be of this equipment, knowing the equipment that you're looking at. So 9.3.1.1 here talks about equipment that's in physical condition 1. And it gives some criteria. And I don't want to go through all the criteria here. You can read through it, but just hitting on a few of them. First and foremost, the equipment in this one looks like it's in new condition. So it's pretty clear what new condition equipment is, and equipment that maybe has some rust or some open KOs or something like that on it where you can tell it's just not new condition. Enclosure is clean, free from moisture intrusion, and it's tight. So no gaskets or anything like that are loose or broken or deteriorating. And then number 5 in each of these kind of gives you a overview. If you're following your EMP or electrical maintenance program, which is what's required by NFPA 70B. You have to have this electrical maintenance program that basically has everything laid out for you as to what you're going to do. And the criteria around that's listed back in Chapter 4, which we're not going to go into fully here. But if you're curious about the electrical maintenance program requirements, you can go back into Chapter 4 and look at those. But so 9.3.1.1, number 5, the previous maintenance has been performed accordance with the electrical maintenance program. So whatever you say you're going to do in that program is what's been done and what's been documented. So that would be condition 1. Condition 2 says the maintenance results deviate from past results or have indicated more frequent maintenance in accordance with manufacturer's published data. The previous maintenance cycle revealed some issues regarding repair or replacement of major equipment components. Things of that nature. We can see this equipment is maybe starting to get some wear and tear on it. Maybe we're not following the electrical maintenance program exactly as needed. When we did follow it, we're starting to find that there's larger components that need to be placed in the system because they're starting to see more wear and tear. So then it's going to fall into condition 2. Condition 3 states that the equipment has missed the last 2 successive maintenance cycles in accordance with the EMP. So we're not doing what we said we're going to do in the EMP. We're not following through. We're not getting the maintenance done. Sub 2, the previous 2 maintenance cycles have revealed issues requiring repair or replacement. So between 1 and 2, we either haven't done the maintenance the last 2 cycles that we said we were going to do, or each time we've done it the last 2 cycles, we're seeing that there are issues with the equipment where we have to replace components again. So as we work through these, we can see condition number 1 is more or less best case scenario. Equipment's like new, it's operating properly, we've done the proper maintenance. Condition 2 is not as good. We're doing some of the things we're supposed to be doing, but not all of them. The equipment's starting to maybe see some wear and tear. And then in condition 3, the equipment's starting to see wear and tear and things of that nature, but we're also not doing what we say we're going to do based on that electrical maintenance program. We've missed a couple cycles or more of performing the maintenance that we should be performing, and as a result, that equipment is probably slipping in its ability to function. So that's what we're looking at when we go back to table 9.2.2 and expand that. Now, if I pin the header here, I can scroll down to photovoltaic systems, and we can see, since that's what we're talking about here today, what's required there. So our scope of work, we've got 5 different things listed, the first being a visual inspection. So in that, if we're falling within condition number 1, we can do our physical or visual inspections out to 60 months or 5 years. If we're in condition 2 with the equipment, 36 months or 3 years would be the visual inspection. If we're down to condition 3 where we're not doing that regular maintenance like we should be, now we're at no more than a year without getting eyes on that equipment and taking a visual inspection of it. Cleaning, lubrication, and mechanical servicing all have reserved areas, and you'll see with NFPA 70B being a new standard in January of 2023, the committee went through and reserved some areas here where they think there's going to need to be some additional focus, additional information gathered to be able to put those items in there with specific criteria around what needs to happen. So we see that in cleaning, lubrication, and mechanical servicing, but then in electrical testing, we see those same conditions and lengths of time or durations as to when it needs to happen based on those conditions. So that's what we have for photovoltaic systems as far as frequency of maintenance and how often it needs to happen. So if we slide back to chapter 30, so we went through frequency of maintenance just now. We're going to jump into 30.3, documentation and labeling. So you'll find in electrical or in NFPA 70B, maintenance documentation is a big component. We need to know what we've done, what needs to be done, what was done when we did it, when certain parts were replaced, things of that nature, so we can manage our equipment and make sure that it's being maintained properly. It's probably going to give us some flags on when equipment maybe needs to be replaced, which will help us so we don't have processes in manufacturing things breaking down that cost us money, because now we've stepped back a little bit and have to replace this equipment. We had downtime. So there's different criteria here. around documentation, what needs to be documented. So the system design and installer with installation and commissioning dates from the initial installation, emergency contacts for the system owner, specifications, electrical schematics, and as-built drawings. And that's a big one. So when we start talking about electrical systems as a whole and all this different equipment that's being maintained in it, we want to have an overview on those drawings of what the equipment is, where it's at, how it's fed, things of that nature, because it's going to help us to manage it, but it's also going to save us time as we do it. So it's important that we have initial schematics and as-built drawings to start from, and then as we make modifications to that system, those are also documented, so we have a working set of drawings that's fluid in real time in with what the equipment we have on site. Signage, markings, and labels need to be addressed with documentation. Mechanical drawings, if applicable. The commissioning manual, test plan, and appropriate test results. Operation and maintenance manuals need to be documented, and then also a materials list of expendable maintenance items such as filters and fuses. Probably not going to have filters necessarily in photovoltaic systems, but we do have fuses that come into play on occasion depending on the equipment. So having those that list available so we can readily go get the right equipment if we need to from a wholesale house or whatnot, to make sure it's plug and play. We've got the right stuff documented that we're going to need. We can go grab it, get it installed, and get everything taken care of. 30.3.2 is a little more definitive on what needs to happen. So you have to have a label that identifies the highest internal DC voltage for combiners, disconnects, and other enclosures that have DC voltage. So when we think about the environment where solar system or PV systems are installed, you get a lot of sunlight exposure. So sometimes these labels, even though we may put one that's made for the environment, over time those labels may start to get that sunlight exposure, start to fade where we can't read them and things of that nature. So as we're maintaining this equipment, it's important to keep an eye on, first, that the labels are actually there, and if they're not, we need to get them there. And then two, if the labels are there and they're starting to see some deterioration or where we can't make out what's on there, then they're going to need to be updated, and redone to make sure we still have that information there readily available. Then we move down into 30.4. So we know our frequency of maintenance based on what we talked about in 30.2. 30.4 gives us the type of maintenance that needs to happen, with 30.4.1 table being the first, and it gives us visual inspections. So visual inspections, we've got specific tasks listed here, 1 through 13. So first being, we're going to look at the front of the PV modules, and with that we're going to do test type 1 or 2, and we'll get to that in a minute. But then in the notes, it tells us the kind of things we're looking for: damage and debris, soiling, discoloration, cracks, broken glass, things of that nature. That's what we're looking for during these visual inspections. Okay? And we've got, 2 through 13 have the same criteria. And we see there's different test types listed. There's 4 of them. There's 1, 1A, 2, and 2A. And at the bottom, it gives us a little quick overview, referencing section 8.3 that we're going to go to here in a minute. But it gives us type 1's an online standard test. Type 1A is an online enhanced test. Type 2 is offline standard test. And type 2A is offline enhanced test. So let's go back real quick to 8.3. And I just want you to see what the breakdown of those tests are. As we just went through them right here in 8.3, they're all listed up here. But this warning that's listed here in 8.3 is key. So it says testing of electrical equipment while it is connected to the source of supply introduces additional hazards to the worker. Workers should understand the hazards and the risks of the test being performed. So with that, we need to look, if we look back at 1 and 1A, those are both online tests, meaning that the system is powered. In that case, there's certainly going to be, electrical safety procedures that we need to follow that would be in accordance with NFPA 70E, the standard for electrical safety in the workplace, and follow that to make sure we're managing, if we need specific PPE or things like that, to manage our risk while we're working on those systems while they are online. Categories 2 and 2A of the tests are offline tests. So in that case, the system is powered down, but we need to also keep in mind, even during those offline tests, there's a means in which we need to turn them off or to where we think they're off, and then verify that they're off by testing for absence of voltage. And with that, now we're back into 70E again. We still need to make sure we're following proper steps to test for absence of voltage, wearing the proper PPE that's necessary, and establishing that electrically safe work condition before we go, oh, okay, this is offline. Now we're in a position where we can work on it. So the difference between the 1 and 1A and 2 and 2A is that enhanced piece. So there's a different criteria around testing that needs to happen at the enhanced test level versus standard test level. And these paragraphs down below go into that a little bit. And there's also some additional information back in the annexes that you can go into. Not going to do that and dive that deep here today, but know that that's there. But the main thing we need to get out of this is 8.3 has the breakdown of these testing types that we're using back in chapter 30 for the periodic maintenance procedures. So when we look back at table 30.4.1, we see those testing types. Now we know what they are, where they can be referenced, and also that we need to keep NFPA 70E in mind as we're performing these tests. 30.4.2 goes into cleaning. It just states that the electrical maintenance program shall determine when and if the installed system requires cleaning. Of course, the manufacturer should be the initial point of reference to see if cleaning is recommended, and if so, what type of products can it be cleaned with to make sure we're not damaging the equipment in any way. So that needs to be taken into consideration. Typically with solar installations being out kind of their own space, you're not getting a lot of chemical residue and stuff like that from industrial processes like you might get on other equipment inside the building, but it's still something that needs to be considered to make sure everything stays clean and functional. Lubrication is reserved for the future. Mechanical servicing is listed in 30.4.4. There's a table for that just lists the one task for tracking mechanical systems, such as the gearbox and drivetrain. We can do type test 1 or 2, so online or offline standard. And then it says we should look at the torque of the bolted mechanical systems and mechanical alignment. This isn't going to be every PV system you have out there. These are the ones that typically are on a drivetrain, that are going to move throughout the day as the sun moves and continue to try to pick up the most amount of sunlight possible. So they're out there, but and we need to maintain those properly if we get to a situation where we're working on those type of systems. And then finally, we have electrical testing, which is in table 30.4.5. And with that, we have 4 different tasks. So we need to test electrical terminations, we need to test grounding and bonding, PV strings and modules, and module interconnections. So the electrical terminations and grounding and bonding are we know those tie really back to the NEC. Make sure those terminations are tight. Over in the notes, you can see that infrared thermography again is being suggested in those applications, because you need to make sure that there's no heat there because of a bad termination or something going bad. Grounding and bonding, of course, is a critical part to the system to make sure that's maintained and we're not losing any connections there. And then the PV strings and module interconnections is more of the equipment side of things. But again, those need to be tested, make sure they're working. Again, you can see for item number 4 for module interconnections task, the only thing recommended there in the notes is the infrared thermography. So as we saw back in the chapter 9, table 9.2.2 around those frequency of maintenance things, we saw that all equipment is recommended for that infrared thermography to happen at a maximum of 1 year. So just again, something to keep in mind as you put your electrical maintenance program into place. So we hope that provided some insight into photovoltaic system maintenance using the 2023 NFPA 70B. For more info about how NFPA LiNK gives you the knowledge you need to get the job done right, please visit nfpa.org/link.